All right, this is the standard for the Newton's second law, and we have a problem here with M1 and M2 connected by a string and a pulley, and they're accelerating. M1's accelerating in that direction, M2 is accelerating in this direction. The mass of M1 is 1.2 kilograms, M2 is 2.6 kilograms. Here's a free body diagram for M1, the normal force, the force of gravity, and the tension from the rope, and then the free body diagram for M2 is the tension of the rope and the force of gravity. So for M1, we would do the sum of forces in the y direction. We get the normal force minus the force of gravity equals 0 because it's not accelerating in the y direction. And in the x direction, you have just the tension pulling on the on M1, which equals ma because it is accelerating in that direction. M2, you have the sum of forces in the x direction. There is no forces in the x direction, so that's just 0. For the y direction, you have the tension minus the gravitational force equals negative ma because it's accelerating in the negative direction. So if you plug in the tension up here, which equals m1a, plug in the tension into this equation right here, you get m1a minus m2g equals negative m2a. You swap some things around to get everything positive, and a is on one side. You get m1a plus m2a equals m2g, and then you factor out the a, you get a times m1 plus m2 equals m2g. After you plug in some numbers, you get this right here. A acceleration equals 2.6 times 9.8 over 2.6 plus 1.2. And the acceleration is 6.7 meters per second squared.